Hi guys, Mrs. A here. Today we are graphing piecewise functions. So to start, we have this function f at x, which is equal to the absolute value of x plus 2 on the interval x less than or equal to negative 1. Then we have negative x squared plus 2 on the interval x greater than negative 1. So we're going to graph this to start. We're going to look at this portion of the function. That represents an absolute value function. If you think about the parent function for an absolute value, let's look down at our grid here. It has the vertex part at the origin, and then it increases to the left and it increases to the right with a slope of 1. If we move that over to the left 2 units because of this horizontal translation, then it's going to look like the same parent function moved over. The vertex will be now at this point -2, 0, and we can graph that. Then we have to think about what happens when x is equal to -1, because that is the break of this interval. So if you plug -1 in for x here, -1 plus 2 gives us +1. So that means that this graph will go through the point -1, +1, and I'm going to put a closed circle there because the interval is x is less than or equal to -1. And then we will have the function in this direction like this, and then in the other direction we draw the other part of our absolute value function, and it's going to look like this in this direction. So that takes care of the first interval for this piecewise function. Now let's look at the second interval. So when x is greater than -1, we're going to have this parabola. Now this parabola, if you think about the parent function, which has a vertex here, goes up like this. This is now going to be flipped over the x-axis and then moved up 2 units. So the vertex goes from here to here so that we can see what it looks like. And then we'll have this point to help us see the graph that's going to form, and then this one, and so on to the right. To the left, because the interval is x is greater than -1, we would have an open circle here at this point. But because it's already filled in from the previous function, then we don't have to worry about that open circle anymore, and this is what we call a continuous piecewise function. So here the two functions meet up at the same point, so that open circle is filled in by the previous function, and this entire piecewise function is continuous. There are no breaks and no jumps here, so we can confirm that it is a continuous function. Now if we didn't want to figure out if it was continuous or not by graphing it, we can do it algebraically. So let's take a look at how we do that. In order to figure out if the piecewise function is continuous algebraically, we're going to take the x value in between the 2 intervals. So in this case, it's going to be the x value of -1, and sub that x value into this equation to see what the corresponding y value would be. And then we're going to do the same thing, sub in the -1 into this equation to see what that corresponding y value would be. So for the first one, if we sub in the -1, we're going to have the absolute value of -1 plus 2, which is the absolute value of 1, which is just 1. Now let's do it again. For this equation, we're going to sub in -1 again. So we get -1 squared plus 2. This is a +1 with a negative. So we have -1 plus 2, which is +1. So in this case, the two y values match up, they are equal. So that's going to tell us that this function will be continuous at that point x equals -1, and that's the only part that's in question when the intervals break up. Thanks for watching Mrs. A Loves Math.